Hello and good afternoon, CSI 158, Section 841 and 847 students at Anne Arundel Community College for the second 8-week term of the Cisco Networking Academy, which is the Routing and Switching Essentials course, CSI 158. Okay, this PacketTracer tutorial is going to be the Skills Integration Challenge tutorial and review, which is PacketTracer Activity 6.6.1.2, where we're going to pull together everything we've been working on to this point in Chapter 6. Route summarization, static routes, router on a stick, and a number of different concepts of inter-VLAN routing, also coming from Chapter 5. All right, so as you can see, we have our addressing table. And here's our scenario. In this activity, we're going to demonstrate and reinforce our ability to configure routers for inter-VLAN communication. We're going to configure some static routes to destinations outside of our network. And we're also going to walk through each of these requirements. So let's jump right in here. So configure inter-VLAN routing on R1 based on the addressing table. So if you take a look at R1, you can see we have a number of sub-interfaces that we're going to be configuring. We'll also check on the serial 000, but for right now, let's go ahead and put that right there. It's in a good spot. Okay. And we'll go from user exec into privilege exec, and we're going to go ahead and do a show run. Let's see what we've got right now. The host name is set. So there's gig 00 and gig 01. We're definitely interested in gig 00. That'll be the interface we'll be manipulating here. The serial interface is already configured for us, and so that's good news. Okay, so let's go to global config mode and int gigabit Ethernet 0/0.10. So we're going to jump right into a sub-interface, and if you remember from the sub-interface configuration, we're going to go ahead and set our encapsulation .1q and then our VLAN number, and we're going to make sure that this corresponds to VLAN number 10, right? We're also going to go ahead and take a look at putting a description on here, and we'll just say this is going to be the VLAN 10 interface for router on a stick. All right, so we've got that, and now we're going to apply the IP address, which is going to be 172.31.10.1, and it's a /24, so convenient subnet mask for us, right? Okay, so we've set the encapsulation. We have also identified the IP address. We've even gone so far as to put a description. And so now let's go ahead and we'll transition to int gigabit Ethernet 00.20, where we will again do our encapsulation .1q20, and we'll put a quick description on here, VLAN 20 interface for router on a stick. Now we're going to add our IP address in here, which is going to be 172.31.20.1, again, /24. So we've got that completed for that interface. And now we're going to go ahead and go into interface gigabit Ethernet 0/0.30. And we're going to do the same thing here. Encapsulation .1q30. And we're going to set the IP address to 172.30.1, 255.255.255.0. We'll throw a quick description on here. VLAN 30 interface for router on a stick. All right, and then we'll go into interface gigabit Ethernet 0/0.88, which is our next interface we're going to configure. We're going to go ahead and do our encapsulation .1q, and this is going to be 88. We'll throw the IP address on here, and that's going to be 172.31.88.1. Again, conveniently a /24. Quick description will be VLAN 88 interface for router on a stick. Okay, and then finally we're going to go int gi 0/0.99 back into the sub interface, where we're going to do an encapsulation of .1q99. We're going to set the IP address to 172.31.99.1. And as you can see, our completion percentage is climbing there description VLAN 99 interface for router on a stick. Okay, so we have definitely configured the inter-VLAN routing components here on router 1. So I'm going to exit out, and we're going to get into Gigabit Ethernet 0/, Gigabit Ethernet 0/0. We have one last command, and that's going to be the no shut. And as you can see, we've received messages here that 0.10, .20, .30, .88, and .99 have changed their state to up. And as you'll notice, the link is green on the router end, and spanning tree is converging here. So we're going to type end, and I'm definitely going to save my configuration at this point, right? Okay, so configure inter-VLAN routing on R1 based on the addressing table. And I feel we've done a solid job there. Okay, you can see the VLAN. You want to make sure that the VLANs correspond, and they do. And so that was router 1. All right, configure trunking on switch 1. And so where are we going to configure trunking? We want to make sure it's gig 11. So we're going to pull the command line up here, go from user exec into privilege exec, and then I'm going to go ahead and do global config mode, and we're going to go in Gigabit Ethernet 1/1. So the first thing I'll do, it looks like it's up, so we'll do the no shut just to be sure. So switch port mode trunk, right? And so now the interface went down, and then the interface immediately came back up. And I'll do switch port trunk encapsulation, or switch port trunk. It doesn't have the encapsulation there for me. All right, so we'll go ahead and leave it the way it is. We'll just leave it with switch port mode trunk. If I do a do show int trunk, we should see that gig 11 is trunking, and it's 802.1q, and the native VLAN is VLAN 1. So I'm going to type end here. We'll save that config. All right, so we configured trunking. Now it says configure 4 directly attached static routes on HQ to each of the VLANs 10, 20, 30, and 88. All right, so directly attached means we're going to be indicating the outgoing interface on the router on which we're configuring those static routes we're being asked to configure. All right, so let's walk through that here on router HQ. So from user exec to privilege exec into global config mode. And so now that I'm here, I want to do 4 directly attached static routes. Let me scroll up just a skosh there. Okay, so here we go. So IP route, and then the network that I'm trying to get to, right? And so that's going to be the network for all of those interfaces that we configured on the router for those VLAN interfaces. So the first one's going to be 172.31.10.0/24, and again, this is going to be directly connected, so we're going to use that interface. So to make sure we get it right, if you watch your completion, I'm at 28, so we should get some points there. We do. And now the easiest way to do this is going to be just to back up over that third octet, and it should be the same. And so there you go. The completion went up 6 more points. So now we'll do 30. Went up 6 more points, and now we're going to do, after 30, it's 88. And finally, we're going to do 99. All right. So there are our 4 directly attached static routes on the HQ router to each of those VLANs, 10, 20, 30, and 88. So there is no 99. All right, so let me pull that out. I was making the assumption they would want it for 99, but they do not. Okay, so I pulled 99 out of there. All right, so configure directly attached static routes on HQ to reach outside host. And so here is the network for outside host. So we're going to add in a new IP route here, and we're trying to get to 209.165.200.30, and it's a /27, so it's 255.255.255, and if it's a /27, it's going to be a 128, and then 192, and then 224. And I'm just adding the values of each octet position. All right, so again, the way I read these route statements here so that they make logical sense is my IP route to get to this network will be through this interface or will go to this next hop IP. And it's asking for directly attached, and I'm on the HQ router, and so I'm going to send this out. It looks like you've got static routes. Configure the primary route through 010, so serial 010. Oh, whoops. I apologize. It looks like I might have a typo there in my address mask, 255.255.224. Oh, that may be the host IP. And let's take a look here. Yes, okay, so they've indicated the host IP address here. All right, not the subnet number. So as that is the host IP, we're going to need to figure out what subnet that would be in. So let's go ahead and take a peek over here real quick. So we've got ourselves a /27. So we know that the last octet is going to be 1, 1, 1, and then 5 zeros. And again, this is the last octet. So this is the 4th octet. Okay? And this is what it would look like with a /27. And so these three values here, 128 and 64 and 32, add up to 224, right? And so if we take a look here, we're trying to find our block size. So 2 to the 5 would be 2 to the 3 is 8, 2 to the 4 is 16, and 2 to the 5 would be 32. So our block size is 32, which means our subnets will be from .0 to .31, and then from .32 over to .63. And so we know that that host, since his IP address is .30, right, for our host, we know that he's in this first subnet here. And so then our subnet number is actually going to be, the network ID is .0, right? Okay, so let me slide back over here real quick. And let's pull this guy back up. So it's inconsistent subnet mask. It is, that's true. And so we're going to change this to 209.165.200.0. And we're going to go with that. And so we have 52 points. So we just jumped to 58. And so that's a good sign. All right, configure the backup route through the serial 011 interface with a 10 administrative distance, right? So an administrative distance of 10. So what we're doing here, and this is some good stuff. So if you were at a company at their headquarters site and you had 2 links out to get to your ISP, or 2 disparate links to one service provider and then one to another service provider, let's say serial 010 goes to AT&T, serial 011 could go to Sprint or Verizon, and we're going to do a floating static. So if the primary route goes down, this route that we're going to add in right now would automatically be inserted into the routing table because it's sitting there waiting to be inserted. And so again, we're going to go to the same network, but this time we're going to go out interface serial 011, and if I do a question mark, you can see distance metric for this route. And so our administrative distance metric will be 10. And so I'm going to hit enter, and our score jumped up, which is always a good sign. So if I do a do show run right now, and let's go down to the static routes, and you can see here are the 2 routes we've inserted. And the good news is our static route of 10 shows up. Now, if I do a do show IP route at this point, you'll notice here's our parent route for 209.165.200/27, and we have one subnet identified, and it's a static route to get there. And the static route is currently out serial 010. So if I were to come into interface serial 010 and say shutdown, and now that link is down, and that was our primary link. And if you notice up here, you can see it went red. So that link is down. Let's see what the do show IP route is going to give me now? And sure enough, take a look at this. We still have a static route out to the outside host subnet, but now automatically it's inserted serial 011 into the routing table. So I'm going to do a no shut, and we're going to bring that interface back up. And again, this interface has a lower administrative distance. The static route on this interface has a lower administrative distance. So if I do a show IP route again, it automatically changes it back. And so this is inserted into the routing table. All right, so this is some good stuff here, and these are scenarios that you really see out there in the real world. All right, so back to our activity. So we've configured the serial 011 interface with an administrative distance of 10. So configure directly attached primary and backup summary routes on ISP for the entire 172.31.0.0/17 address space. All right, so let me type end here. We're going to write mem. And save our configuration. We're going to close down the HQ router. And so now it's asking me on ISP, the ISP router, to configure, let me slide this guy over here. There we go. Directly attached primary and backup routes for the entire 172.31.0.0/17 space. And so I believe they may be implying that that is the summary route. So we'll go from user exec to privilege exec in a global config, and we'll see here shortly. So I'm going to type in IP route 172.31.0.0, and then a /17 is a 255.255.128.0. And so it wants directly attached primary and backups. My primary path is going to go through serial 0/1/1. And let's see what that looks like. We go from 66 points to 75, so we've got it. So again, they are providing us, this is very generous here, so we do not have to work the summarization out by hand. And then the backup route would be serial 0/1/0 with an administrative distance of 25. Again, indicating that this is a floating static that will be inserted if and only if our primary route fails. So I'm on this router, so let me go ahead and do a do show IP route. Let's take a look at our routing table. So here is the summary route of a 172.31.0.0/17. It's a static, and it shows it's directly connected out serial 011, which again, that's our primary path. So if I go into serial 011 and I type shut, and I shut the interface down, you can see the link is now gone red. If I do a do show IP route, we still have our interface here. I'm sorry, we still have our static route here, but now it has magically changed and auto-magically changed for us to serial 010 with an administrative distance of 25. And so this is a great way to test the reliability and the failover capabilities of your floating static. All right, so now I'm going to type no shut to bring that interface back up. And if I do a do show IP route really quick, let's see if we're back over that. And we are. The state is up. And as you can see here, 172.31.0.0/17 is now going, or I'm sorry, still was going through because I typed it really quick before the interface came up. And now that the interface is up, let's take a look, and we should be going out serial 011, and we are. All right, so that is the functionality, the purpose, and the value of a floating static route. Okay, so configure a directly attached default route to router 1. So let's save this here, make sure. All right, on ISP. So now we're back on router 1, and it would like us to configure a directly attached default route. So we'll go from user exec into privilege exec into global config. And we're going to do the quad zeros here. So there's our default route, and it says that it needs to be directly attached. And so our default route would be out serial 000, because again, this is for traffic for all of the PCs that we have down there in VLAN 10, 20, 30, etc. If they're pushing traffic up to router R1 and it's not for any of the local subnets there or anything that's being routed by the router on a stick, the inter VLAN routing being done there, then this is the route that they're going to take. And it would be out serial 000, and then it would get pushed over to headquarters. So there's our directly attached. So we go from 84 points to 92. And then finally it says verify connectivity by making sure all the PCs can ping outside host. And so from here we'll do a write mem. We've saved that, and so let's come on over to PCA, and we're going to ping 209.165.200.30. And again, this is definitely going to ARP out, and we're going to end up hitting that default route that we have. And there we go, fantastic, that works. And now I'm going to try that from PCB. And as you can see, we're actually being scored on testing the connectivity. So I'll pull the desktop up, and then we're going to ping 209.165.200.30. All right, and now our default gateway has the entry for that network. It knows how to get there. So now we'll try PCC. Ping 209.165.200.30. All right, so we've got connectivity there, and we'll check PCD. And one last time, 209.165.200.30. All right, so we've got success from all of our PCs. Let me go ahead and scroll over, so we're good there. So we're 92 out of 100. So let's take a look at our check results and see what it is we might have missed. Okay. So native VLAN. So it looks like we missed the native VLAN on gig 1.1. And so it's looking for us to add that native VLAN in, and it looks like it's going to be 99. Let's check our address table here. I may have to slide over. And it looks like gig 099 is going to be the native VLAN, right? As you can see, it's right here. So we're double checking. All right, so we're going to come to the switch, and we're going to go from user exec into privilege exec to global config into the interface gig 1.1. Whoops. Gigabit 1/1, and then we're going to do switch port trunk native VLAN 99. And I'm going to type in, and we're going to save this config. Now we're at 98% complete, and I'm going to let this sit, because what you should see is by default, the native VLAN is VLAN 1, and so right now we have a native VLAN mismatch between what's on the switch and what's on the router. And I'm curious to see if this is going to generate a message for us, or if we simply need to go back up into the router, make the configuration for gig 0.99 as the native VLAN. So if we were to do check results, and we'll come back and take a look at the screen there in a second, the final task that we have is for the interface there that is going to be our native VLAN. So let's close this, and now let's pull the switch back up. So it doesn't look like we're seeing anything. Between switches, you'll definitely receive a native VLAN mismatch error. All right, so let's go ahead, and we've already saved our config. We'll close out by making the connection here on the router. So we're going to go to global config mode, and then we're going to go into interface gigabit 0/0.99. And if I do a do show run right now, you'll see for the interfaces we have, there's 88 and there's 99. So I'm going to go ahead and adjust this encapsulation .1q 99, and if I do a question mark, you'll see that this is where we make that declaration native. And so this should take our score from 98 to 100. It just did. I'm going to save this off. This is not going to change our ability to connect through to the PCs. And so that completes the Skills Integration Challenge for Chapter 6, Activity PacketTracer 6.6.1.2. All right, I'll see everybody this evening. Have a great night.